Okay, and the last trend we're going to talk about is the opposite of ionization energy, and this is called electron affinity. So now remember, with ionization energy, let's see here, we're removing an electron, okay? With electron affinity, you're absorbing an electron, okay? And for most things, addition of an electron is exothermic, so that's why the values are negative. And so I'm not going to spend a whole lot of time with this, but I will say there is a general increase as you go up and a general increase as you go over. And so what does that mean, more negative? Well, more negative actually means it's more favorable. They want to have that electron. And that makes good sense when you think about it, because like if we pick on like, francium or cesium or something, right? They have a ton of electrons. They don't want any more, okay? But as we go up, okay, those things have less electrons, so they're more willing to take on those electrons because they have less to begin with, all right? And similarly, as we go across, we're increasing the number of protons. So because we're increasing the number of protons as we go across, then those things will want more electrons, okay? And of course, exceptions do occur. So if we look at the series of iodide, bromide, chloride, and then fluoride here, fluoride is supposed to go way up, but it actually goes down instead. And the explanation for fluorine here is because the 2p orbital is really small. So there's just not enough room for it to take on. I mean, well, there is, and we know that fluorine wants that electron really bad. But chlorine, as you can see, wants it more. And that's because the size of the fluorine, the very small size of fluorine, does make it somewhat difficult for it to absorb that extra electron, okay? So in general, just have a good working idea of these trends. Electron affinity increases as we go up and over, okay? Ionization energy also increases as you go up and over, but remember that they mean the opposite thing. Okay, so it's the same trend, but it's the opposite. Okay, and then let's see. So with ionic radii, we can only compare things that have the same electronic structure. And within that same electronic structure, the things that are more negatively charged are bigger. The things that are more positively charged are smaller. And then now there's a general, so with atomic radii, there's a general decrease as you go up and over. Or I could say a general increase as you go right to left and top to bottom. Okay? So that is it. This is a monster of a chapter. We will spend discussion this week and as well as next week going over this stuff. So please don't get behind. Make sure that you've done everything for part 1. Do everything for part 2. And we'll be good to go, folks. Okay, I'll see you later.